Hi. So in this chapter, we're going to talk about discrete random variables. And discrete random variables are exactly what it shows, right? Discrete meaning, remember the countable numbers. Random meaning we select random and then the variable. And so we can recall back in chapter 1 when we talked about discrete meaning countable meaning 1, 2, 3. And continuous is everything of countable and everything in between. And we're going to learn that in the future chapters. For this chapter, we're just going to talk about the countable numbers, which is a really nice set of numbers because all we have are the whole numbers and the positive whole numbers, and we really like that. Okay, so a random variable describes the outcomes of a statistical experiment in words. So we assign that random variable by a letter capital X. It's usually capital X. And it's just known to be discrete if it has a countable number of values. And so random variable, again, we can write it out and then we just denote it by a capital X. All right, and then the small x would be given as a number, like which event of this random variable are we on? Which trial are we on? If I toss a coin 3 times, the random variable is tossing the coin and how many heads I get, and x is like 0 heads, 1 head, 2 heads, 3 heads, right? So in the example below, we can see that that's what we did. We said, well, let's toss a coin 3 times, and then these are all the outcomes. Well, if I want to say that the random variable is the number of heads when I toss the coins, that means I could either get no heads, 1 head, 2 heads, 3 heads, and therefore little x would be that event. 0, no heads, 1 head, right, 2 heads, or 3 heads. So the random variable tells us the event, and then we have to see, well, what kind of events do we have? And that's the little x. So when we get to 4.1, which is a PDF, stands for probability distribution function for a discrete random variable, our outcomes will be in whole numbers, right? Countable numbers, and we'll be able to build a probability distribution function from those discrete random variables. So a probability distribution is exactly what you think it is. It's a bunch of probabilities, and it's a distribution, but it's specifically to the random variable. And it's in form of a table, graph, or mathematical formula. So we're going to kind of take a look at all 3 of these. There are a couple characteristics of the discrete random variable that are really important. The first one is that if I'd added up all the probabilities from the discrete probability distribution, it should add up to exactly 1. Not over 1, not under 1, exactly 1. Why? Because that's the maximum probability that we can ever obtain, right? Which is certain probability, right? And then all probabilities have to be between 0 and 1. Okay, so let's take a look and determine whether the tables below give a probability distribution for a random variable. So you'll notice that here in the x are all 0, 1, 2, 3, right? Whole positive numbers. And the probabilities are on the right side of the table. Okay, so if I want to determine whether this is a probability distribution, I would first make sure that the sum of all the probabilities are equal to 1. So if I added up all these probabilities, let's say on the calculator, I would have 0.16 plus 0.18 plus 0.22 plus 0.1 plus 0.3 plus 0.01. And that equals 0.97. So the moment that it fails the first characteristic, this is not a probability distribution. It has to sum to 1. We don't get a choice in it. Okay, so now let's go ahead and try B. Let's do 1. Let's see if the sum of all the probabilities is equal to 1. Right? So if I did that in the calculator, in this case, I could see that it's not because it looks identical to this one here, except a negative. So not only does it fail number 1, but also number 2, because if you look at it, are all the probabilities between 0 and 1? Right? And the answer is no. And so it fails both, and this is for sure not a probability distribution. All they need to be is add up to 1 and be between 0 and 1. So now let's go ahead and check characteristic 1 and add up all the probabilities and check if it's 1. So I'll go back here, and it looks like it's the same. 0.16, 0.18, 0.22, 0.10, 0.3, and then 0.04. And that is equal to 1. So perfect. Excellent. The second one we see are all the probabilities between 0 and 1. And we can see from the table that all of them are between 0 and 1, which is really nice. And we see that it fits the criteria for a probability distribution. And this is a probability distribution. Probability distribution. Okay, so let's go ahead and go to an example with Netflix. So the below table shows the probability distribution for the random variable x, so that we don't even need to check. It's already a probability distribution that's given to us. And x represents the number of movies streamed on Netflix each month. What is the probability of streaming at least 3 movies each month? And what is the probability of streaming less than 3 movies? So there's 2 questions here. The first one is, what is the probability of streaming? So x is the number of movies streamed on Netflix. What if this x is at least 3 movies? Well, at least 3, does that include 3? Yeah, it does. So at least 3 would be 3, 4, and 5. So I would add 0.1 plus 0.03 plus 0.01. They're already probabilities, so we don't have to calculate anything. We just need to add. So the probability of us streaming at least 3 movies is 0.14. Okay. The second question asks, find the probability of streaming less than 3 movies. Well, less than 3 movies could be 0, 1, and 2. And we could add those up if we wanted to, right? And have 0.06 plus 0.58 plus 0.22. Or I could say that another way is saying, well, I already found 3, 4, and 5. And these all add up to be 1, wouldn't that be the same as saying 1 minus 0.14? Or in other words, 1 minus the probability of x at least 3. And notice I would get 0.86. So if I went to my calculator and I added up 0.06 plus 0.58 plus 0.22, I would get 0.86, right? But if I realize on the table that having less than 3 is just 1 minus the sum of these, which I just found in the first part, it's also still 0.86. So there are a couple of ways to do it, and numbers you can always play with. But please get used to seeing this relationship between x less than 3 and x at least 3, because then you could easily just use your work before and work smarter, not harder, and use it in the second part. These will be really beneficial to us in the near future of those inequality exchanges.